Hello and welcome to the 8th video of my Pygame tutorial. Now, if you remember last time, what we were doing is basically we had this issue with spawning. So I'm just going to run the program again, and it's a little bit off the screen, so we'll bring it back onto the screen. If you remember, the issue was we had a lot of red boxes. Now, the reason there are so many red boxes is because they just kind of double every second. And the reason they're doubling every second is we're calling spawn in the update, which means basically every single enemy object is its own enemy spawner. So every second, every single enemy that's on the map, because 30 frames is our target, and since we run at 30 frames every second, we spawn an enemy. So every enemy, every second, spawns an enemy. Since we start with 2, after 1 second we have 4, after 2 seconds we have 8, after 3 seconds we have 16, after 4 seconds we have 32, and you see how this quickly gets out of hand. Now, let's actually fix this so this isn't part of the enemy class. Let's actually make the spawner part of just the class, the file, like the basic enemy.py, the Python file, rather than the enemy class. And to do that, we're just going to basically move the define function outside of it. And of course, change up everything's spelling because we don't actually have a self or not. And I just did something crazy and I don't know what it was. Anyway, so we're going to define spawn, and this will be part of the enemy, so we can call it pretty simply. We need a couple of things. So we need a cooldown, and I'm just going to call this spawn cooldown. We're going to set that equal to 0, and then spawn cooldown max. And we're going to set this one equal to 90. So every 3 seconds, basically, we will spawn an enemy. Actually, that is quite a lot. Every 5 seconds probably would be better for this example. I don't even think we generate ammo that fast. You know what? Just for the sake of it, we'll make it 300 seconds. I know, I'm changing my mind. This is going to be more variable based on, like how long the level's going on or whatever. So it kind of changes itself up. So now we just have to swap these in. And we don't actually need .cooldown. Control V. So if spawn cooldown is less than or equal to 0, spawn cooldown is going to be spawn cooldown max. And it's not going to be plus equal. This is going to be a direct assignment. So spawn cooldown equals spawn cooldown max. That way we can control how everything operates. Now we have a couple issues with this. So new enemies and enemies.add new enemy. Everything works, except why can't we look at this? Why is this giving us an error? Well, it's an unresolved reference, and that's because we can't actually see this thing. Now first off, this is all tabbed over, needs to be tabbed over one more, and so does this stuff. Just formatting stuff right now, that's a problem. Python actually cares about its formatting, so you do have to make sure everything is tabbed properly, otherwise you will get problems, but we still have the error where we can't see this. And the reason we can't see it is because it's a global variable right now, and this function isn't set up to use global variables. So I believe if you just say global, and then spawn cooldown, and then we'll also use spawn cooldown max, this will allow us to look at the global versions of those, and that will let us use them for our actual function. And the reasons, now spawn itself is going to be called every second, so spawn cooldown minus equals 1, just means, every second this thing's going to spawn. What we could actually do, and it might be better, maybe, is set spawn up to, take how many do you want to spawn a minute, basically, and then it will, calculate its own stuff based on that. Maybe we'll do that later. For now, this works, and it'll be good enough for now. So, we changed up how spawn is, which means how are we going to spawn our enemies? Well, we actually have to change up our main file now. So let's go over to main, and you know how we say from basic enemy import enemy? We actually have to change this wording to just import basic enemy. And the reason we have to change it to just import basic enemy is because now we're not just looking at the enemy class, we're looking at the file, because we have this thing called spawn, and we have the class enemy, so we need both now. So enemies equals enemy.enemies. Well, this isn't quite accurate anymore. Now it's going to be basic enemy.enemy.enemies. And of course, I can never spell this right. enemy. And this should give us the proper reference now. So of course, enemy1 is an enemy. It's not actually an enemy. Now technically it's a basic enemy dot enemy. Because of course we're adding an extra layer of reference. Which is why we just wanted to import the class originally, because then we don't have to give it this extra layer of referencing to look at. Let's see, is that all of our reference problems? Looks to be it. So that should be okay. Let's see, what else do we want to change? We need to actually do the spawning. So player.update, enemies.update. Let's add spawning somewhere in here, I guess. So, another little comment. Spawning. And then all we have to say is basic enemy dot spawn. And every single tick, since we're currently in our main game loop, every single tick this will run the enemy.spawn function, which means we'll spawn an enemy every second. Of course, later on we probably want to put arguments in it, but it's good the way it is for now. So let's take a look. Now our enemies should spawn. Let's actually just make sure that they spawn a little more naturally now. There's one. So let's move this over. There's one enemy, since of course, we just got a new spawn. There's another one. And about 10 seconds later, we should get even another one. Let's just test for that last one, and then we'll actually get into the good stuff. Yep, looks like it's working correctly. So that's all we needed to test. Now, what we want to do is, in order for the actual aiming of the new thing, where we have that green box at the bottom, and we have the bullets shoot down toward it, in order for that to happen, we have to change something about the player. And that is its get target. Now, get target all by itself gets the target and assigns it to the bullet, and then the bullet reacts to it. Now we actually want to change this a little bit. And I'm going to call this set target just so it's more clear, and then it's actually going to take a target. So instead of giving it the mouse position, we're going to give it a target now. So we can get rid of this entirely. And now we say cursor 0. Well, all we say now is, let's see, target at 0. And target is going to be the same format as cursor. It's still going to be a tuple, so it's going to, look something like this, where we have X and Y inside the parentheses. This is what it's going to look like. So the target at 0 and the target at 1 will represent the X and Y of the target. So it'll react the exact same way. And that's the only difference we're doing. That's all we have to change about getTarget is change it so that it takes its target instead. And now when we do shoot, if we can find it, that's in the bullet. So sorry, not the player, but that's the bullet. It's our set target in the bullet class. And what we have to change about the shoot is when we do getTarget, bullet.getTarget, we need to now pass it a target. And I'm just going to pass it targ as its target for now. And targ is going to be passed through the shoot. So let's see, where do we call shoot? We call that in main, I do believe. Shoot is now going to have to, of course, take targ as well. So we're just kind of passing it through at this point. And now we'll go to main and take a look at where we're shooting. So if mouse 0, so the left mouse button is pressed, we shoot. And what do we shoot? We're going to shoot our cursor. And what exactly is our cursor? Well, it's this thing. Cursor equals pygame.mouse.getPosition. This is the same thing. All we're doing is we're passing it into the player.shoot method. The player.shoot method is passing it into the bullet.getTarget method. And then the bullet.getTarget is setting its target equal to what it's being passed, which means now the bullets can be given any target, not just the mouse cursor, but any target that we hand them, and they will be able to fire at that direction. That's very good, since what we're planning on doing is, with our example here, what we want to do is we want to be able to hold space and have them shoot toward the green thing, completely independent of the mouse targeting. So we can fire letters down toward this thing without having to really worry about the actual left click of this. That way we can target basically two things at once using the same function instead of having to create a separate function to handle that by itself. Okay, so let's take a look at what we actually want to do with creating the objective. So we need another class, and of course we'll come down here for it and make sure I'm tabbed incorrectly. Yep. So class, do I tab over one more? No, I don't. Oh, class is lowercase, that's why. I haven't done this in a little bit. Class objective. Just trying to remember what's the syntax for this. Does this need to be a sprite? I do not believe it needs to be a sprite, so I'm going to not make it a sprite. Class objective, define init self. Sometimes that auto-completes, and that's really weird. And defining its initializer for itself, we're going to create three things that we're going to ask this to do for us. So the objective is basically a string of text. And so we have something called self.win message, and that is going to be equal to, some type of win message. So if this is spelled, then you win. And it's all happy about that. And then we also have something called self.display message. And this is nothing. Because currently, when we start, we don't display anything. We don't have any words. And then our win message is our target. Like, what are we trying to display? So when we, shoot a letter, say we look at our player's inventory, we go, hey, do you have an eye in your inventory? And the player goes, yes. Then it goes, okay, shoot that eye at our objective. And when the eye hits the objective, add the eye to, or add the character that you shot to the win message. And then it goes, okay, the next thing I'm looking for is this F. And it's like, do you have that in the player's inventory? And it's like, yes, I do. Okay, shoot it at the objective, and when it collides, add the F. Okay, we have a space. How do we handle that? Well, we can't have ammo spaces, so what I'm going to do to handle it is just add it. And then it's going to go, okay, player inventory, do you have a T? And it's like, yes, I do. Okay, shoot it at the objective. And then once these two are equal to each other, then the objective is complete. Currently, though, display message is set to false when we construct this thing. We update it later. And the last thing I'm going to do is self.redraw. And self.redraw, we're going to define right now, is going to be the thing that handles the image, because every time it gets hit, we have to redraw the image. Now, we don't want to redraw every single frame when we don't have to. So the only time that this image is going to change how it looks is when it gets hit by a word, which means that's the only time we should ever have to update its image by adding a character. So we're going to create self.image, and we're going to set that equal to a Pygame surface of, let's see, our width is 1,000, so why not go with 800? I suppose 800 could work. A Pygame surface of 800 by, 150 should be okay. Self.rect. Actually, do we get the rectangle yet? Maybe. No, I don't think I have to. So self.text equals some type of text. If you remember, we have utils.get font, and then of course, we'll go with courier new. Size equals, I want to say 16 will be enough. Utils.getFont.render. Is this how we do this? And then we render the message, which is going to be self.displayMessage. We say true for anti-aliasing, and then we give it a color, which is going to be utils.black. So we're rendering the text, and now all we have to do is say self.image.blit self.text to where do we want to blit it? Well, it's 150 tall, so why not 25? Whoops, that's a tuple. So 25 by 25 should be okay. And then self.rect equals self.image.getRect. So what's happening here is, of course, we create a simple Pygame surface image, we create the text, and then we blit the text onto the image, and we need to set a color. So self.image.fill. Let's go with like the example and say utils. Oh, we do have green. Okay. I didn't know if I actually created green yet or not. Apparently I did. All right. So I want to say this is everything. Since when we hit redraw, what's going to happen is we're going to create a new surface. Basically, we're going to update it. We only have to fill it, to be honest. We don't have to create a brand new surface. So we don't have to be that inefficient. So I can always do this way. And that way, whenever we redraw, we just blank out the image like we've always done by refilling the image. We recreate the text with a new display message after it's been updated, and then we blit the text onto the screen, and we set the rect to where we want it to go. So that reminds me, we need to reset the position. Does this thing move? I guess if it did move, maybe we do want it to move, maybe we don't. If we did, then we would set the rectangle here. So I'm just going to set it here anyway, just to allow us that option. It doesn't really matter. It's not that hard to change. But every time it redraws, I guess it'll just reset its position. So self.rect.x equals, since we're playing 1000 and we have an 800 wide, we should make this be placed at 100. Self.rect.y should equal, since it's 150 tall, 600 tall, we want this to be what, 450? That way it just kind of sits at the bottom. Yeah, that should be okay. We could probably get away with this just being 100, to be honest, since we're not using a 100 sized font, and then this can just be a flat 500. There. This should be good for the objective. So let's actually start implementing the objective itself. Now, let's take one look. The player is going to be the thing that handles the objective. Basically, the letter dumping is what we'll call it. So let's see. Shoot, move ammo. Let's do it below shoot. So we'll create another function in the player to handle this. And let's call this dump. We could call it dump ammo. We could call it do objective, I guess. Do objective works. And this is going to basically have a couple things. So when we call do objective, which is when we're going to hit spacebar, and we'll get to that in a little bit, when we actually call do objective, it first needs to check something. And in order, what it needs to check is the objective, so object, I don't like object or obj, it makes me think of objv. Yeah, objective, that'll work. So we need to actually give it the objective, because it needs to first check if the objective dot win message, and I kind of want the little things to pop up. So basically, if the objective dot win message is not equal to the objective dot display message, then that's when we, can do stuff. So I want this to pop up, so I'll actually handle when this thing gets called right now. That way I can have, the little pop-ups of giving me ideas and kind of shortcuts. So we'll go to the main to just make sure this thing gets called when it needs to. So let's see, active key, we'll put it here. Just like the other keys, we can say if active key is the pygame.key underscore space, then we can just say player.do objective with the objv, the objective. And the objv we will create right now. So player active, whoops, I didn't want to do that. Let's put that back over there. Make sure it's tabbed properly. And then we can say objv equals objective. And we have an imported objective. So from generic player, import player active and objective. And now we can actually create our objective, correct? objv is an objective. Good. That means it's working. So now, when we do this, we should have objv dot, display message and win message. Okay, so now it's working. So if the win message is not equal to the display message, or a better way of wording this would actually be if the objective dot win if the objective, why are you not working? Dot display message is not equal to objective dot win message, then do stuff. So basically, if our display message, which is the thing the user can read, is not equal to the winning message, then we do stuff. And what do? Well, first we need to check one thing. So if the messages aren't equal to each other, we need to get something. And I'm going to call this the temp letter. So template is going to be equal to, how would I word this? Objective dot win message at a position. So strings, the way they work in Python, is you can name a string. So objective.winMessage is our string, and we can give it square brackets to get the place on it. So position 0 is going to be the first character in the string. Position 1 is the second character in the string. Position 2 is the third character in the string. So we know what it is. So if we said 0, then when we look at the win message, we'd always return I. If we said 1, we'd always return F. If we said 2, we'd always return the space. If we said 3, we'd always return the T. That's how this works. So what are we looking for? What position are we looking at? Well, what we're looking at is the objective, or rather the length of the objective.display message. And the reason we're looking at the length is the length returns the length of the message. So we're looking for the next character to add into the display message. That's what we're doing always. So currently the length of this message is 0. So we're going to look at the I, because that's the 0th place. Now when we add the I, the length of the display message is going to be 1. So we're going to look at the F, and then we're going to grab the F. And then once we add that, the length of the display message is 2. And we're going to look at the space. That's how that's going to work. So it's pretty simple to look at it that way. So when we do the objective, we're going to grab the temp letter. So the temporary letter, that's just a holder for the letter that we're looking at, because that's the letter we need. And now, because we can't handle spaces, we're just going to take a shortcut and say if temp letter equals a space, then all we're going to do is say objective dot display message plus equals temp-let, which is the temp letter. We're going to add it to it, and then we're just going to return. And the reason we're going to return is because we want to stop here. If it's equal to space, just add the space to it and ignore the rest of this function. We don't want to do anything else. Now, some functions, when you return, generally you can return a value like 6 or 7. It doesn't really matter. And the function, when you return that, you say, down here you would say something like, variable equals do objective, and then do objective would return, 6 or 7, and then variable would be equal to 6 or 7. That's how it's normally used. However, when you use it on a void function, like we're doing here, like do objective doesn't return anything. It's considered a void function because it doesn't return a value. We just say do objective. We don't say, temp variable equals do objective. And when we don't return anything and we just say return like this, it basically stops the code. So say this is equal to a space. It goes, if it's equal to a space, do this, return. And then it will ignore anything we put down here. So if it's not equal to a space, then we actually have to do something because it's not returning at this point. And of course, the if statement didn't trigger. So what we have to do is for, how do we do this? For ammo in player active dot ammo, and I believe we're actually looking at the class with this one. Wait, we're actually in the player function. Whoops, total confusion there. So for ammo in self dot ammo, we can do this nice and easy. If ammo equals temp letter dot upper. Is that lowercase temp letter dot? If ammo equals temp let dot upper, I want to say uppercase is correct. And what this is looking at is for every ammo in our current set of ammo, if the ammo is equal to the temporary letter, and the reason we do temporary letter dot upper is because the ammo is always in uppercase. If you remember, we're pulling our ammo from, what's the string? Right here, the character list. All of these are always uppercase, so we need to make sure it looks the same. So when we say temp letter dot upper, it's just converting the temp letter to an uppercase, because uppercase and lowercase actually have different ASCII values. And most languages, just to point this out, don't actually do well with saying if a letter is equal to another letter, because they don't handle that very well. And this actually isn't a letter, I just realized we'll change that in a moment. But most of the time you can't use the double equals to say they're equivalent to each other. You actually have to use like dot equals or something. But since Python uses ASCII, which is like a character library, it'll automatically convert these to integer values and compare them that way. So it's kind of nice to us for doing that. Now, just realizing ammo isn't a character. So we need to fix that. So bullets, they have a name. Actually, I set this up earlier and I forgot to change it back. So if you remember, the self.image was .render instead of self.name. What we had here was self.random choice from the character list. I've actually just changed this slightly by giving it a name. Basically, I'm storing this value. So the random choice from the character list, which is the image on the bullet, I'm just storing it in something called self.name. That's the one thing, and then of course I'm rendering that instead of rendering the random choice in the character list. That gives me access to the name, or the letter. So if ammo.name equals temp_letter.upper, then this is the bullet we're looking for, this is the bullet we want, then we can say self.ammo.remove ammo. Actually, that could be confusing. So we'll call them shots again, I guess. For shot, if shot.name, then we will remove the shot, which is the letter, the piece of ammunition we're kind of shooting out. Then self.ammo.remove it. So now once we've removed the particular ammo from the list, meaning it's no longer in our player's inventory, because we don't want to be able to dump the ammo and shoot the ammo at our enemy, we want it to all be the same one. So once it's removed, what we have to say is shot.rec.x equals self.rec.x plus 25. The reason it's plus 25 is because we know what the center of our image should look like. So self.rec.y plus 25. Since the shots, or not the shots, but yeah, the images are smaller than our actual player. I don't actually know how big they are, but basically plus 25 will almost center it. I mean, if we wanted to, I suppose, be perfectly accurate, then we could say self.rec.x equals this one, plus half of it. But the plus 25 just centers it close enough for me to not be super picky about it. So once we center the shot, we still need to do some stuff with it. We need to do shot.get target, and if you remember, we give the target a tuple. So what are we giving it? Well, our objective.rec.x plus the objective.rec.width over 2, and the objective.rec.y plus the objective.rec.height. And I'm actually going to leave height as it is and not do over 2, just so it aims at the bottom of the image versus the center. Since the image is on the bottom, however, now that I think about it, if the image is not going to be on the bottom of the screen, we want it to aim at the center. So we get its target, and then we say, what is that thing called? So the shoot, what is it? Self.bullets.add bullet. So self.bullets.add bullet, not bullet, but the shot. Because of course we need the shot to start rendering itself as a bullet, meaning it needs to start doing, the fly towards its target in a straight line. So once that's done, I believe this is everything we need. What we can do also is we can say if at this point, do we want to say here actually? No, we don't want to say it in the shooting mechanism. What we want to say it is later on when we actually test the collisions of this. So I'm going to say that this function is done. No, we still need to return. So again with the return. Now, for shot in self.ammo, this means for every single bullet in our ammunition, in our player object, if it's equal to the temp_letter.upper, shoot the ammo, is what it's saying. Which means, say we're looking for S, and we're holding down spacebar. Let's say there are 100 S's in our player object. We're going to fire all 100 of those at this. We're going to fire all 100 at the objective because that's what we're telling the computer to do. We're saying for every single shot, shoot it if it's equal to what we're looking for. Well, what we're looking for won't update until the bullet hits the target, which means we can't just, it's not as simple as just that. So what we have to do is we have to return. And the reason we have to return is because we need to stop it. So once we hit return, we're basically going to stop going through that list. We're just going to return nothing in our function call, and we're going to stop looking through this list of all the things that we do. That way, it doesn't, waste all of our time. Now that I actually look at the time on this video, I want to change just something. I want to match how I did this in the example. So what I'm just going to say is the objective.displayMessage plus equals the temporary letter. And what this is going to do is basically when we shoot the shot, it's going to add it to the display message. And then what it's going to do is we don't update it here. We're going to update it in a moment, but we first need to actually draw this thing. So define update takes one argument, the game window, and then what we're going to say is game window dot blit. What is this thing? Self.image at self.rect. And of course the update is just basically drawing the objective. And of course over here we need to call it. So objective.update on the game window, just like the player and the enemies. There we go. And what else do we need? We need to test for the collision, which is when we redraw the thing. So this is the last thing we're going to end up doing here, because there's an issue involved with doing the collisions for, when the bullet collides with the message, then having the message add that word to it. There's an issue with that in the logic of this. So what we're going to say is objective collision equals pygame.sprite collide with the objective and player.bullets, and the bullets do die, so we're going to say true. Now, this part might confuse you. Objective is not a sprite. It doesn't have to be a sprite. The way the collision pygame.sprite.spriteCollide works is it looks for self.rect. That's all it cares about. So the fact that we called our rectangle self.rect means it won't actually throw an error. If we called it something else, like self.rectangle, the full thing, not rect, R-E-C-T exactly, then it wouldn't know what it's looking for. So it doesn't technically have to be a sprite. The groups, in fact, do have to be sprites, though, because this one actually looks at the sprite groups. Since player.bullets is a sprite group and enemies is a sprite group, and this second one in the sprite collide argument does have to be a group, but the actual single entity argument doesn't have to be, which is why this is going to work. And then we can just say for bullet in objective collision. What do we want to do? We just want to do objective.redraw. And that's all we want to do. So for bullet in collision, do we want to for every bullet in collision? For bullet in collision, the bullets there We redraw for every bullet that hits. I guess that works. It might be better to say if bullet in collision or if objective collision, meaning if there's a bullet there, then we redraw, but this should work the way it is. So let's test it, I guess, since we haven't really run woo. It's not too big of a box. This could be a problem. Doesn't like clicking. Bullet.getTarg. Line 61 and shoot. Player.shoot cursor. Traceback most. What? Bullet attribute. Oh, we didn't rename it in our player shooting. That's what's wrong. So remember how we changed this thing to set target to the target? Well, in our player, we didn't change the name of this. So we also didn't use it properly here in do objective. It's not get target. If you remember, it's set target. And we also need to change it here to set target. And those are the only two things running it, so it should work now. There we go. Kill those. I'm considering a couple of things, like making it so that we don't spawn random letters, since this might take a little while to get the first one. I don't even remember what our first letter technically is. Yeah, this might be a problem. Come on, I'm holding space and nothing's happening. It could just be because we don't have the letter, or it could be because something isn't working properly. I do not know. So what are we looking for letters? If this is spelled, then you win. Okay. So how about we change this slightly? Character, just temporary, of course. We're going to look for IFTHIS just to get the first, set of this thing running properly. And basically this will let us know if we get it right, because when we spawn these ones, they should spawn much more quickly. So there we have an I. We're holding space, nothing is happening. This is a problem. And after a moment of looking into it, temp_letter.upper is actually a function. I didn't know that. So when we were calling temp_letter.upper without the two brackets, it was never going to work and never was destined to work, since we weren't actually calling the function. So now it should work. There we go. We shot an I and an F, shot a T. There we go. If this is, and of course that's all we actually are generating for letters, but now it's properly working, and you saw the bullets actually got shot toward it. Now, here's the problem with the other way it's going to work, and then we'll finish up this and we'll handle it next time. So when we shoot our letters toward the objective, so I can't actually do it because it's full now, but when we shoot them toward the objective, the objective will actually absorb bullets that hit it, which is something we need to probably handle, since if the objective is going to float around and we don't want it to infinitely absorb shots, we probably want it to, only absorb shots if it needs them. And two, if we only add the letter when it collides with the objective, think about it this way. See how quickly we shoot? When we actually shoot at the objective, what the issue is when we shoot, there's a delay between when it hits it. And only when it hits it are we going to recognize we need the next letter. So it's possible that when we hold space, we'll fire 3 or 4 different shots, and they'll all be the exact same letter, because that's what the objective is looking for. The objective is looking for an I, and we hold down space. We'll fire 3 I's, the first I will hit it, and we'll go, oh look, I finally got my I that I needed. Because there's that delay. So we actually have to handle that delay, and we also have to handle this weird collision where, if it hits it, it deletes it, but we don't always want the shot to be deleted. Maybe we do want that. Maybe we want this objective to act as a big barricade, and you can't shoot through it and it just absorbs infinite amounts of shots. Or maybe you want the objective to only absorb the shot that hits it. We're going to change it up so it only absorbs the shot that hits it, and we're also going to change it up so that it updates when we hit it. So it doesn't accidentally shoot more than one shot when we update when we hit it, and it also updates better when we do that. So you know what? I'm just gonna do it anyway. So objective.displayMessage plus equals the temp letter. How about I'm just going to move this over to show you what I mean, I guess. So we're going to move this over here, objective.redraw. What we're going to do first is we're going to say Basically this statement, objective.displayMessage plus equals bullet.name. And this is the template error. This is basically the bullet that hits it, it's going to update its display message. So this is the exact same thing code-wise, the exact same letter. But you see we have a bunch of eyes, right? Now you're going to notice we shoot all eyes. That's all we shot, and that's all we updated. That's not the message. That's not the display message. It's because there's that delay. It's looking for an I. Now it's looking for an S, right? And it's completely off kilter right now because it doesn't know what it wants. So the display message isn't equal to the current message, but the letter we're looking for is 0. It doesn't actually exist. And then there's also this problem. Notice how it's just updating based on what we shoot at it? Well, that's because we're updating it when it collides. We're not updating it based on any real logic. So if we want the collisions to work, we have a big problem. And there's that problem right there with the spacebar, index out of range. That one is caused because remember how we're looking for the letter with the display message? Well, if the display message is longer than the win message, then we're looking into a null area, and that's an issue. Anyway, this is episode 8 of my tutorial. We'll try and fix those issues next time, and I hope to see you then.